Hi, my name is Kaylee, and you're watching the Youth Code Jam Bits and Bytes Puzzle Club video. Today, we're going to be going over the type of puzzle that we did in this session, just in case you maybe forgot how to do it or got stuck doing one of your own or just want a refresher. So today's video is on self-referential puzzles. And if you look over to the left-hand side of the screen, there are some questions and some multiple choice answers. It looks pretty normal at first until you read the questions. Then it gets really confusing really quickly. So today we're going to be going through how to solve one of these. So here's how a self-referential puzzle works. Each puzzle has a number of multiple choice questions, and all the questions are about the puzzle itself. There's only one correct answer for each question, and according to Brainzilla, the solution can be found without too much trial and error, but there might be a little bit, and that's okay. So here are a few strategies for solving a self-referential puzzle. You can scan through the questions to look for a good starting point, and you can use trees to help you keep track of where you are in the puzzle. And that's the method that I will be demoing today. So here's our first example to work through together. This is the puzzle from earlier. We've got our 3 questions, multiple choice answers, and it's not always the best idea to start with number 1, like it is for something that often looks like this. We're going to look at the dependencies to start off. So which question all of the questions depend on. So if we look, number 1 says, what is the answer to the second question? So that one depends on question 2. So question 1 depends on question 2. For number 2, it says how many correct answers are B. Well, we'd have to look at all of the questions to see if their answers are B or not, right? So question 2 depends on all questions. And for number 3, is there a question with a correct answer A? In order to figure that out, we would have to look at all of the questions again. So question 3 depends on all questions. Now, in order to try to simplify our lives, really we could start with any question, but in order to take the simplest approach, I'm going to start by guessing for question 1 because it has the fewest dependencies. So here are our 3 possible guesses along the top. I have a question 1 could equal A, it could equal B, it could equal C, or it could equal D. But first we're going to try to guess that question 1 equals A and see where that takes us. So if question 1 is equal to A, then the answer to the second question then must be equal to A. So we can circle this, and on our tree, which is just a group of different questions with arrows showing our dependencies, if question 1 equals A, then question 2 equals A, and so I have this over here, and that means 0 of the correct answers are B. All right, so then what does that say about question 3? If none of the correct answers are B, then this can't be the answer to, oh wait, let's read question 3 real quick. Is there a question with a correct answer A? I see 1, I see 2, so yes, 2 questions, which means that question 3 has got to equal either C or D, because we don't know if this one's going to be A yet. So at least 2, right? But we're not sure about 3 yet. So I'm going to guess that this is the correct answer, and we're going to trace down this line of the tree and see if these answers make sense together. So if question 1 is equal to A, then the answer to the second question is A. That checks out. If question 2 is equal to A, then there are 0 correct answers that are B. Based on this tree that we're using, that makes sense. And if question 3 equals C, then there are 2 questions with the correct answer A. And this side of the tree, 1, 2, yep, that looks right. So these are our answers. Whichever side of the tree we trace that all the answers make sense together. So that would be where question 1 is equal to A, where question 2 is equal to A, and question 3 is equal to C. Now, for this next example, things are going to get a bit more complicated. You may not have needed the tree for the first one, but I would recommend trying this method out for the second one. There are a few more questions and a few more different ways we could go. So let's see. We have all of these questions here, and I skipped the checking the dependencies because right off the bat I can see that question 3 is the answer to question 5 is, which means its only dependency is question 5. So I'm going to start by guessing for the answer to question 3. So question 3 could equal A, it could be B, the answer could be C, or it could be D. And so here are all of my choices. They're not connected because they're different choices. They're not on the same tree, on the same scenario. So if question 3 is equal to A, then the answer is B here. So question 5 must be equal to B. So we're going to jump down to question 5. The answer must be B, and I've added it to my tree up here. So if the answer to question 3 is B, then the answer to question 3 must be B. Based on this, so we have the answer to question 5 is, if we're guessing it's A, then the answer to question 5 is B. And if the answer to 5 is B, then the answer to question 3 must also be B. And so we have A, B, B. But hang on, I see a contradiction here. The answer to question 3 can't be both A and B. So that tells us that there's a wrong answer in this tree, and so we can just cross it out. We know that this isn't right. This isn't right here. So let's look at this guess, where question 3 is equal to B. Well, if question 3 is equal to B, then the answer to question 5 must be D. So we'll add that to our tree as our guess. And if the answer to question 5 is D, then the answer to question 3 must be A. It'll come back in a second. But based on this one down here, the answer to question 3 must be A. Now we hit another contradiction. The answer to question 3 can't be B and A at the same time, kind of like last time. So we know that there's some faulty logic here. This can't be our answer, so let's just cross that right out. And on to guessing that question 3 might be equal to C. Well, what happens if question 3 is equal to C? Let's find out. If question 3 is equal to C, then the answer to question 5 must be A. And if the answer to question 5 is equal to A, the answer to question 3 must be C. And that checks out because in this scenario, the answer to question 3 is always C, and the answer to question 5 is A. So that works. But these kind of questions go back and forth with each other, and there's not really anything that we're told about the other questions. So we're going to leave this be and come back to it. It's not wrong, so we're not going to put an X through it. But we're going to see what happens if we guess that question 3 is equal to D. So what happens then? If question 3 is equal to D, then the answer to question 5 must be C. We'll add that to our tree over there. And if question 5 is equal to C, then the answer to question 3 must be D. This one also makes sense. Question 3 is always equal to D, and question 5 is equal to C. So these are our only two viable scenarios, the only two ways that it could be. So we're going to get rid of those other two, space these out, because we're going to be drawing more layers to our tree. So since the answers to question 3 and 5 don't really tell us anything else about the rest of the questions, about 1, 2, and 4, we're going to have to make another guess. We can remove this layer because it's duplicates, we don't lose any information if we take this off because we still have the answers to questions 3 and 5 up here. So for space, I'm just going to take those off, but you're welcome to keep them on. All right, so we know based on this that the answer to question 3 must be C or D. So we can cross out A and B as options since the answer has to be either C or D. And for question 5, we can do the same. So the answer to question 5 must be A or C. So we can cross off B and D. We know that those are not possible for question 5. Now let's make a guess about question 1. Let's see. The answer that is not an answer to any other question. Well, let's look at this tree first. These are 2 scenarios. So we're going to ignore this one for now, and we're going to pretend that these are the correct answers. We're going to go with this guess for now. So based on this tree here and just this tree, the answer that is not a question to any other question would either be B or D, right? Because we already have A and C as answers to our questions. So question 1 would either have to equal B or equal D. Now let's look at question 2. The only question with the same answer as this one is, let's see. So let's look at this side of the tree first. Follow this one path of arrows all the way down. So the only question with the same answer as this one. What if our answer was A? So that would mean the only answer with the same answer as question 2 is number 3. So they would both have to be A. But question 3 is not equal to A, so that's not going to work. The only question with the same answer as this one, could it be number 1? Which means that both number 1 and number 2's answers are B, because they're supposed to have the same answer. Well, on this side of the tree, that makes sense, because question 1 is equal to B, so B is an option. Could it be that the only question with the same answer as this one is number 5, whose answer is C? Well, not in this tree, because here our question 5 is equal to A, so the answer can't be C. So far the only one it could be is B. The only question with the same answer as this one is number 4, which would mean that 2 and 4 are both equal to D. Let's see. 2 and 4, it could be that one because we don't have anything about question 4 yet. So the only possible answers of questions that could have the same answer as number 2 are B and D. So question 2 could equal B, or question 2 could equal D. Now let's look at this next question. The first question whose answer is A. Well, based on this side of the tree that we're going to work off of right now, we'll ignore this one and come back to it. The only question whose answer is A, so far that I see, is number 5. So either the answer could be D, number 5, or what if this is the first question whose answer is A? Then maybe this one's A. So our answers will be either A or D. Oh, excuse me, C or D, because that would mean that C is, or that number 4 is the first question whose answer is A. So the first question whose answer is A is either got to be 4 or 5, which means C or D are the answer. So we're going to go down the row, and if you look at this chain, it has the answers guesses for questions 1 through 5 each once. And if that doesn't work, we could try tracing a different path down the tree. So we could go 1, 2, 3, 4, 5, but we definitely don't want to be looking at a whole group like this, because wherever the tree splits, we have to choose one way or not the other, or the other. And we're going to start with this left-hand side because that's the one that we've been working on. So let's check this highlighted chain of possible answers. We already know that these two make sense together, so let's start here. If question 1 is equal to B, the answer that is not an answer to any other question should be B. But the answer to question 2 is B on this side of the tree. So we already see a problem here. We have a contradiction between these two with question 1. So that tells us that this part of the tree has a wrong answer in it somewhere. So we're just going to cut off that branch and that's gone. And so now we're going to work on a different part of the tree. Now we're going to try to work out the problem if the answer to question 2 is D. We're going to follow this path right here, this chain right here. So if question 2 is equal to D, then the first question whose answer is A is got to be, well, on this tree, this side of the tree, I see that only question 5 is equal to A. So it could be that question 5 is the first question with the answer A, or that question 4 is the first question whose answer is A. So again, we see that questions 4 or 5 will be the first question whose answer is A. So the answer to question 4 must be C or D. Now we're going to check this chain. So again, I've already checked this part up here, so I'm going to start with question 1. The answer that is not an answer to any other question is B. So B cannot be the answer to any other questions on this chain. That looks correct to me. How about question 2? The only question with the same answer as this one is number 4, which means that number 4 should also be D. But it's not. So we have an issue here between these two parts of the tree. So since we know that there's an error there, we're just gonna trim that part of our tree and keep working. I see another chain of 5. Let's try to check this chain. So question 1 is equal to B, means that B is not the answer to any other question. It looks like that's correct. None of these are B except for this question 1. Let's keep going. If question 2 is equal to D, then the only question with the same answer as this one is number 4. So number 4 should also be D. And yep, that checks out with the part of the tree that we're looking at. Okay, on to question 4. The first question whose answer is A is, the answer is D. So number 5. Is question 5 the first question whose answer is A? Yes. Yes, it is. It's right here. So all of these answers in this highlighted chain make sense together, which means that since there are no contradictions, that's got to be the answer to our puzzle. So if you look, I just took off these other 3 little bubbles here, and I lined these up really straight and neat, and these are the answers to our puzzle. So question 1 is equal to B, question 2 is equal to D, question 3 is equal to C, question 4 is equal to D, and question 5 is equal to A. Thank you so much for watching this video today, and a big thank you for Brainzilla for providing us all of these puzzles. If you enjoyed this video, here are some things that you can do. You could share this video with a friend who also likes puzzles. You can go to www.brainzilla.com for more puzzles to try on your own, or you can come to our next Bits and Bytes live session where we'll be working on some more things with Puzzle Club. Thank you so much, and I hope you have a great rest of your day.